gonna pause. And I will just share a short video.
Hello, welcome to Stream 2. I'm Maria Rosa Idare, and I'm a researcher fellow at the Department of Education of Roma Tre University in Italy. I'm here to welcome you and introduce you to the session. The Learning Ideas Conference brings together researchers and practitioners from around the world to discuss, innovate and create. So it's a place where the international community gathers to find new paths, solutions and innovations in learning and technology for the workplace and higher education. Today's session name is Stream 2, and I'm so happy to kick it off to the first presenters of this session, Dr. Rainer Wuttwacher, from the Technical University of Munich, the Institute for Lifelong Learning in Germany, and Professor Holly Ott, Rosenheim University of Applied Sciences from Munich, Germany. And I kindly ask to Dr. Rainer Wuttwacher to share his screen. The presentation title is a Lean Six Sigma Certification MOOC, Balancing Standard Materials and Individual Guidance to help participants implement real projects. Dr. Rainer Wuttwacher, Six Sigma Master Black Belt and formerly with Siemens Management Consulting, is today an independent business consultant and a senior lecturer at the Technical University of Munich, with more than 25 years of experience managing and implementing Six Sigma and Lean process improvement projects, both in production and in service. We are using the Q&A box for questions and the chat for technical issues, so please post your question in the Q&A box and we will respond to them at the end of the presentation. I'd like to remind you that the presentation will last about 45 minutes or 50 minutes, and we'll have 10 minutes for more questions. So please, Dr. Rainer Wuttwacher, please start your presentation.
Maria Miranda, can you see my screen?
Yes, perfectly.
Yes,
Great,
perfect.
thank you. So Maria Miranda, it's my sincere pleasure and a big honor to be with you and your audience today. Thank you very much for having me. And as you already mentioned, this is a contribution from Professor Dr. Holly Ott and from me. And to give you just a short overview, you also mentioned my background. I'm a psychologist and I'm a Six Sigma Master Black Belt. Started my professional career at Siemens as a developer for user interfaces, for hardware and software, and then switched to the management consulting for Lean and Six Sigma. Actually, I'm an independent business consultant for 25 years now, with experience in production and service, and I'm a senior lecturer at Technical University of Munich at the Institute of Lifelong Learning. This is the content of my presentation. So we will start with an introduction to Lean Six Sigma, and I will introduce our chef, our little chef de cookie. Then I will present you some facts about our Lean Six Sigma MOOCs. And the core of this presentation will be about the development of our MOOCs and our trade-off in the balance of standardized and individual guidance of learners. And the same is true for not only for the development of our MOOCs, but also for the operation of our MOOCs, also here balancing standardized and individual guidance. And finally, I hope there will be some questions from you, and I hope that we will have a nice discussion there. So to introduce Six Sigma, you should know that Six Sigma is a concept with three meanings. First of all, it's a management system to increase customer satisfaction and to reduce cost in business processes. And for this purpose, companies educate about 5 to 10% of their employees as Six Sigma yellow belts, as Six Sigma green belts, and black belts. And hopefully this company also has some kind of improvement system with a continuous flow of improvement topics. And these topics are then evaluated and selected and implemented as Six Sigma projects, and for the new candidates also as certification projects. The second meaning of Six Sigma is its performance level. So if you talk about Six Sigma, there is also, of course, 5 Sigma and 4.3 Sigma. So it's like a grade in a school, which indicates the performance of a certain process. But it's a little bit more in statistics. So it's also about descriptive and inferential statistics. And finally, what we want to do and what we do is a data-based root cause analysis of problems. So Six Sigma is basically about a scientifically driven problem solving. And we do this with a certain method, which consists of a set of 5 phases. This method, the DMAIC phases, define, measure, analyze, improve, and control. And there are a set of tools within these phases. And we tried and we implemented several practical principles and a scientific approach to this method, and which is suitable basically for any business process, but we also extended the view. All of these perspectives, all of these meanings are intended to improve operational excellence. The focus of our MOOCs is on the statistics and is on the method of Six Sigma, not so much on the management system itself. So if you remember Lean and Six Sigma management systems to improve business processes in production and service, let me give you some examples of certification projects in the past that might indicate the variety and the relevance of Six Sigma projects. This is a classical example. We had pinholes and cracks in laminate material of blister packs, and this was implemented in production, and Six Sigma originated in production at Motorola and was developed in 1987. Another type of project is, this is an example for a service project here. It's about the delayed publication, wrong prices, and translation errors in an online shop. Another example focused on the development is about wrong dimensions in technical drawings for deep supply units. And we then generalize the approach for any repeated process to also offer certification projects, not only to employees, but also to students and job seekers. And this is a project actually running in Lagos in Nigeria about blocked sewers and resulting flooding in a city center. Let me now please introduce our Lean Six Sigma project scenario. And this is one scenario which is where we developed a complete project, and this is the start and the basis, the anchor for all of our students. And the task is to transfer the ideas of this scenario to their own project. And in the first step, it's important that the problem within a process is identified, because problems in Six Sigma are the anchor, the start for any project. And if you like, then you can participate when I show this video, and maybe you would like to draw a list and list all the problems that you observe in this video. So I need to switch to the video. Stop sharing. You will see this in double speed. Typically, in a normal speed, it takes, here it is. It takes 5 minutes, so it will take 2.5 minutes for us.
Hi, I'm Laura. I'm procurement, logistic, and production service, and I take care that the kitchen doesn't burn down.
Ooh, I'm safe. What's my name? Vanille. Wie? Platz. Nochmal.
Das wäre jetzt was.
Gemandelte.
Gemandelte?
Gemandelte Eier nur in Liter, aber Liter. So lecker.
Ja? Genau, so haben wir die Hände sauber auf.
Da war ein Joghurtstück.
Hey, the cookies are here. Happy birthday. You are 1 week early. Oh, bleh.
So the first task for our students is now to, let me switch back to the slides here. So the first task is for our students is to identify the problems. And I prepared this already for you. So we primarily anchor problems in the outputs of our processes. And this can be final outputs, and this can be also intermediate outputs. So what you might have observed is that the cookie taste is bad. And you might also have observed that the cookie delivery was 1 week early. This was probably a little bit difficult to understand, but this was about the delivery and the early delivery. You could also see that the cookie diameter was larger than the tin. So here already a little bit more specified, cookie diameter larger than 10 centimeters. You could also observe that there was a waste of ingredients, which we can directly relate also to the cookies. And you could see that there was a waste of energy, the high degree of how they preheated the oven. And what you now might have already observed is that there is a certain structure how we formalize the problems. The first thing is, and the first task is to focus on the right object. And this is the final product here, so it's all about the cookies. The second part here in this table is about attributes. So basically what we see and the source of variation is not the object itself, but these are always attributes. And here we can discriminate the taste, the diameter, the delivery, ingredients, energy. And now here, the third part of this description of this scheme is the deviation. So here we can only say cookie tastes bad. It's not very precise yet. We can be a little bit more precise here with the cookie diameter being more than 10 centimeters and so on. So what we require here, and this is a quite a big requirement, that participants first find out the correct objects. And this can be, of course, a cookie. And this can but also be teaching a video of our course material. And this can also be an immaterial object like a decision or an answer, for example, in a call center. And these objects, cookie video decision, they are characterized by lots of attributes. And here, for example, the taste is important. For the videos, for our learning material, the audience retention is important. And for a decision, the content may be important. And the deviation here for the cookie tastes bad, we have the video audience retention may be discontinued, and the decision content may be a false alarm. This structure is very important for us to have a very early idea already in the early phase of the project to see whether we would be later able to measure our problems. We can further classify these objects, these problems to 3 categories: to quality, to the availability and consumption, so the cookie taste and the cookie diameter. These are aspects of quality. The delivery is about availability, and the ingredients waste and energy waste, this is about consumption of inputs and resources. Then we need to discriminate in the beginning what causes or what negative influences you might also have observed. And here you might have seen that we had an order, and the order specification on taste of the cookies was quite ambiguous. The cookies should taste like those of grandma. So this might be a negative influence on the taste of our cookies. And you could see that the ingredients were determined individually, and this is also a source of variability which could affect the taste of our cookies. You also, of course, observed that our little chef nibbled chocolate from the ingredients several times, and that she manipulated the timer setup, and that the cookies were shaped variably, and that the date on the calendar was wrong, and that the oven was extremely preheated. So here we assign and classify these negative influences in a process model. So we assign the order to the input, of course. To the input, we would assign a recipe, or this individually determining the ingredients, to the methods, how we do the things. We discriminate resources like our chef herself, like the timer, the oven, and we have certain activities which we cannot directly assign to one of these resources or methods. This is, for example, the nibbling of the chocolate. The next part can show you already the first picture, or a kind of a twin of the problem and of the complete situation, which gives you a clear structure about the causal relationships. So the first step will be to identify the problem. So here we have the problems again: the cookie tastes bad, the delivery is 1 week early, and so on. We have the triggering causes of the order specification, the ambiguous order specification, the ingredients individually determined, and we have effects of the problems. And this is very important to discriminate problems from their effects. And the effect of the bad taste, for example, is that the customer is dissatisfied. Another effect could be that the customer claims for compensation. And of course, there are costs of the company for the wasted ingredients, and they overall lead to revenue losses of the company. And to complete the picture, you see here already some ideas we have on the solution. So ingredients individually determined, maybe we use cookie blanks, or we forbid nibbling, and we determine the correct oven temperature. This discrimination between these components to discriminate problems from their causes, from their effects, and from their solutions is very often, and most of us are not very good. At least this is one of my experiences. What you see here is the result from a newly hired CFO in a quite big company. And he asked for problems in the different sites he visited of the company, and he got 211 responses. So he asked for problems and got responses, and 76% of these 211 responses were about solutions. So you ask someone for a problem and you get an idea for a solution. 11% were about causes, 3% were problems, the class that he asked for, 1% was about effects, and 10% was not defined at all. And you might experience this also in everyday life. If you talk to your colleagues, what you hear also in the news, you get similar results if you ask what is the problem, for example, of the COVID pandemic. You will get lots of different answers what the problem is. So this basic tree, this first structure of a problem cause effect solution twin will further be specified and statistically analyzed within the project to find then solutions for the important root causes. This is the basic idea of Six Sigma. Let me give you some facts about our MOOCs before we come to the core. So we offer 3 courses for Yellow Belt certification on edX. They all together, the first one about define and measure, about the DMAIC method, the second one about analyze, improve, control, also the DMAIC method, and the third one about lean production. They all together lead to an edX verified certificate and to the Lean Six Sigma Yellow Belt certificate. And additionally, we offer in the 4th course the Green Belt certification project. And there are 3 different paths. There is the classical path for individual business projects for companies. So this is aimed at employees at companies. But as you might remember, we widened the scope. So we additionally offer a predefined community project about environmental littering in the respective hometown of the participant. And this project is follows the United Nations Sustainable Development Goals number 11. And the 3rd project type we offer is an award project for an outstanding project idea, also following one of these Sustainable Development Goals. And this is directed to anyone who is interested. New for us, or new on the market, is thus that we now have a complete online business projects for companies. So this is the traditional way, now completely online. We have, with our predefined community project, we have a new target group and we have a new application area. And for the award project, we also have a new target group, a new application area, and this is free of charge. So all these 3 paths lead to our Lean Six Sigma Green Belt certification. Some facts about before we make this deep dive. So we have the first 3 courses for the Yellow Belt. They are completely held online, and the Green Belt certification project is online, supported online. We have additional lectures once a week. We have additional coaching, and we have reviews of the project in these 5 phases of the DMAIC method. We have these 3 paths for individual business projects made up of lectures, individual coaching and reviews. Our predefined community project for the students, there is no individual coaching necessary. So here we have the lectures and the reviews, and the award project is already very individual. So here we need lectures plus group coaching and reviews. To see how big the market and the interest in Six Sigma is, let me show you some data from Google Trends. These are data from the last year, and the blue lines on the right side show that the keyword Six Sigma training is more often searched for than Scrum. Scrum is actually also very prominent and very, very popular, part of the agile methods. And if the blue line is on the left side, there was a time where people around the world searched more frequently for Scrum training. So there's a difference. Six Sigma is still a little bit more popular, and maybe this comparison might help you to get an idea about the popularity of Six Sigma in the world. We published the Yellow Belt in 2015 and the Green Belt last year in 2020. Actually, we have about 300,000 participants. with an average age of 29 years. 50% of them are in the age of 26 to 40, and we have 15% who are older than 41 years. We have 28 female participants and 72 male participants. 57 have a university degree, overall from 120 countries, primarily from India, then the United States and Germany. We also have a quite nice resonance. Two of our four MOOCs are highest ranked in the class central business courses based on 125,000 feedbacks on the courses, and all of our 4 Six Sigma MOOCs are highest rated in the class central Six Sigma courses. This is our course team, Professor Ott, Professor Martin Grunow, and Tina Kumpuli from our management team. We have guest lecturers from 3M, ASQ, Infineon, Intel, and the Lean Network Institute. So let's dive in what this is about and tell you a little bit more about the development of our MOOCs. And MOOCs are, of course, also processes. The development of a MOOC is a process, and also the operation of the MOOC is a process. And Six Sigma and Lean are aimed to improve processes. So it seems natural to apply Six Sigma to the development of a Six Sigma MOOC and also to the operation of a Six Sigma MOOC. And the conflict we experience here was to find the balance between standardized material that we offer and the individual guidance that is still necessary. Let me show you one of the first tools of Six Sigma. This is a Carnot chart, and the Carnot chart shows six selected challenges and problems from us, challenges for the development and problems in the operation of our MOOCs. The underlying Kano model helps us to prioritize the requirements, and we did it in the define phase, so in the first phase of the development, and in the operation by expert assessment. So there are no data behind, these are just expert assessments according to the importance of a requirement. And there are 3 different types of requirements. There are must-bes, there is more or less is better, and there are delighter. And here you can see the different characteristics for these requirements. So this is the characteristic for a must-be. And it was a must-be for us that the teaching objectives we have are conform, more than 99% conform to the American Society of Quality and to the International Society for Six Sigma Professionals. So this is a must-be that we needed, that we wanted and needed to fulfill, that to assure that our certifications will be accepted worldwide. Why is this a must-be? So here you can see a must-be is a requirement that where the reaction of the customer, of the learner, or more general, the stakeholder, is indifferent. This is a requirement that the customer just requires as given. So as you expect that you can make phone calls with your phone. It changes you will perceive an immediate problem if you do not fill the requirement. So if you can make calls with your phone, the customer will be indifferent. But if the calls are broken within 50% of the time, then the customer will be, of course, angry. So here, this is how you can discriminate this must-be characteristic from, for example, the more is better characteristic. So this says the more you give from this, and sometimes the less you give from this and have from this, the more satisfied is the customer. From being angry if you do not fulfill this, up to complete satisfaction and excitement if you completely fulfill this. And we have these 3 requirements on a must-be level also for the development. So we wanted more than 90% of our teaching objectives illustrated by scenarios. The third one was a must-be again, which I will introduce. We wanted that the concept, how we conduct and support the project, has an application validity of more than 95%. So if a student identifies a basically suitable topic for Six Sigma, then we wanted to assure that our concept can lead him to a successful implementation and also evaluation of the project. This is also a must be. The number 4, the requirement, the challenge we had is also oriented to the development of our course. And it says that the tools that we provide should give the learner a guidance through the project in more than 80% of the steps. And here more is better. So the more we can guide the student, the better for the student. The 5th requirement we have is about the project support effort. So you saw that we have the courses, we have the material online, but we also have online lectures, and we need sometimes, of course, additionally support participants individually. But we want to keep the effort, the individual effort, low for our standard project, for our students, and it would be a problem for us if our support or effort per participant is larger than 1 hour. And the final requirement that I will talk about here is about our general support effort from our management team, about inquiries that are that we additionally receive to our course. Let's start with the second requirement. Teaching objectives should have a illustration by scenarios in more than 90%. So this is a picture, an extract from our yellow belt, and overall the yellow belt is structured in about 30 hours of video lectures. We have interactive statistical exercises. We have interactive case studies and mini projects, and these were developed in cooperation with German companies. And as you can see here, this is a manufacturer of hiking shoes. And so they get an insight also students in industry and in different scenarios of industry. Overall, there are about 500 practices and homework problems. And this is the basics material for our yellow belt. This is completely held online. The additional green belt for the implementation of the project is structured in one consistent example project, which you already saw. This is our Cookie to Chef, 5 minutes, very short. We have about 6 hours of video lectures. We have a book with the same content, mirroring the content of the videos. We have a software, which I will give you a short demonstration, a guiding software, a project storybook template where the students need to document their project. And there are about 60 tasks to get these projects identified, evaluated, implemented, and evaluated. So with the yellow belt, we address the competence levels to remember, understand, and apply, and complete this by the competence levels of apply, analyze, evaluate, and create. Let's switch to the second requirement, or the third one, the second that I want to show here. We wanted that the project concept, the underlying concept, has an application validity of more than 95%, not only to the business processes, but also to these community processes. And the challenge here was to manage the balance, the trade-off between the valid application for a wide range of projects. So it's a topic about generality, and to have additionally a reliable and standardized guidance in each project phase, which represents the power of our concept. And overall, we want to assure to minimize our support efforts for projects. And we did this by adapting the DMAC method to scientific principles. And this is shown here. What we want from our students is to differentiate their observations of the reality. So we have these three components: the observations of reality, we have the model behind where the observations should be mapped, we have the statistics, and these three components, reality, model, and statistics, are related by assumptions. So we draw assumptions from reality and integrate them into our model. So you observed our cookies, and you see here there's a difference between these cookies in two attributes. So they differ in size and they differ in color. And this is what we want, that students focus not only on the correct and the right object for the project, the right outputs, but also that they are able to discriminate the attributes, and of course then later evaluate the most important attributes. We also want that they think about relationships between influences in the process. For example, the timer here, the timer setup, the relationship between the timer setup and the attributes of our outputs. Then they need to translate their assumptions into the model. So we're talking about inputs into the process. This is the chocolate and the eggs we receive. We have a method like the recipe. We have resources like our chef and the oven. We have certain activities where the work is done, where the value is created. And we have, of course, outputs and intermediate outputs, like the shopping list. We have a dough, we have the cookies raw, the cookies baked, and finally the cookies delivered. So we have certain stages of intermediate outputs, all related to certain influences in this model. And the integration then to the DMIC is that we also integrated the problem-solving perspective here. So problems are always, we simply define, problems are always related to outputs, and the causes are related to the method, to the activity, to the resources, and to the input. So this is an important circle and an important requirement and the most important transfer step to go from our cookie example and to map the observations from their specific project into this model. Then translate the assumptions in corresponding statistical hypotheses to collect data, to test these hypotheses, and to confirm the assumption or to reject these assumptions. So what we want is that the students not only implement just one specific project, but get some general competence to translate qualitative observations in quantitative descriptions, and finally in causal explanations. We needed, of course, it was necessary to transfer this project concept in specific guidance. So here we have the fourth requirement we have, our tools that we developed, and we wanted to assure that these tools can guide more than 80 steps, more than 80% of the steps of the student. This poster here shows all the tools the students need to apply, and they all have a certain structure. So these tools are all linked in a seamless input, activity, and output chain. And I will show you the project topic in just a minute. So this is how it works. We see you would first enter an observed weakness, like you observed in our cookie scenario, and there are certain weaknesses there. Then your task would be to describe the weakness, to identify a first draft of the cause and the problem, evaluate the risk, and then the output that is generated from the tool, it gives you a summary, some interpretations and recommendations on the inputs you made into the tool, and there are some data from this project topic extracted, and these data from the project topic extracted are then transferred to the next tool, to the project definition. So this next tool is based on these data already developed, and there are again activities and again an output and so on. So this leads to this seamless input activity output chain. Let me call this, name this a kind of macro guidance along these tools, and within the tools we have some kind of micro guidance. So most of the tools have a hierarchical information collection structure via a controlled dialogue for each tool. How does this work? The tool asks a question and you enter an answer. And then the next question is built up and is specified. The second question then is specified by a part or by the answer you have already given to the first question. And then you give an answer to the second question. And again, your answer is integrated in the third question and you give a new answer and so on. And finally, you will get a summary and you can check this, or the student should check this, and you will probably and hopefully see that there might be sometimes nonsense as an input. So getting these summary and this check would allow the student to go back and adapt some of these entries to follow this formalization and schematization and parameterization that we apply. So I would like to give you a short demonstration how this works. So this is the Sigma guide, and let me show you the first tool, this project topic again. And this is directed to all employees of a company, typically without any previous knowledge on Six Sigma. So there are 7 questions overall. And the first question is to describe, simply to describe the weakness of the observed weakness of the process, and maybe a weakness in the output, and describe the observations in some statements and answering the questions here. Which weakness did you observe? What are its causes? So these are assumptions derived from the first observations, and what are the consequences? And oops, this is, I already prepared here so that I do not need to enter the text here. So what you see here, bakery cookie dough chef has several problems. Most important, sometimes cookie tastes bad. Sometimes the cookies are delivered too early. Additionally, there is some waste of ingredients and energy. Well, now then the second question comes up. And what we require here is an answer to 2 half sentences, which should make a complete sentence overall. So let's have a look at the first one. Orders or tasks we receive decrease the quality of our products or services. It could also be that orders or tasks we receive decrease the availability of our products or increase the waste. So let's think about the orders that we receive, this ambiguous order in the beginning of the cookie. This might be the most important problem we saw. And you can see already here the first output here, a structure, a feedback. Orders or tasks we receive decrease the quality of products and services. Now this content is integrated in the third question. Which tasks or orders do you mean? So if we take, for example, the material, other inputs we receive, or if it's about the method, the instructions, procedures, algorithms, so the methods that guide our activities, like the recipe, is assumed to be a cause for a decrease of quality, or the machines, the equipment, and other resources, or simply the activity. Then the third question immediately changes, which activity do you mean? So let's switch to the order. We assume it's about the order, and the order decreases the quality of our products and services as one of our primary products. And then we are asked to specify this with which specific task or order do you mean? And this is our order for birthday. And which specific product or service is affected. And in our scenario, this is, of course, of our cookies. Now we ask about data collection, because this is important that also in the beginning we get some ideas whether we would later also get here the idea whether a data collection later would be possible. Can you basically collect individual data on each incoming order? And maybe we say, yes, we can. And can you basically collect individual data on each resulting cookie? And maybe also, yes, to make it simple. Then we will have what I would like to show here. We get also a kind of interpretation of this. Individual data can be collected on the cause, order birthday, and on the problem cookie. This measurement condition is typical for Six Sigma projects. So if we say, for example, we can collect data on the input, but not on the output, we would get some information. Please check again, because this is an unusual situation that we can collect data on inputs, but not on the outputs. And there's some recommendation what to do. And then let me do this quite quick. How frequently does the cause occur? How frequently can the quality defect can be detected at the place where it occurs? How severe is the problem, the effect of the problem on the costs of the company? How severe is the effect on the irritation of internal, external customer? And finally, estimate the minimum and maximum expected performance improvement, and estimate the share your own department can contribute. And this then leads to the documentation, and we come to the relevance and summary and relevance and suitability of the project topic, where we have not only the summary, but also some recommendations about our project. This guidance is then continued from the first tool to the second tool, and this is what we basically do and how we want to assure the guidance of our participants. Let me show you just one more important part that you might be interested in. So one of the, sorry. So one important part for the operation of our MOOC is that we want to keep the effort per individual student for our standardized project below 1 hour. And we asked our students, sometimes we make some ad hoc service in our Facebook group, and we had a question here, what our students prefer, an excellent book over a boring video, and this is preferred by 71% of the students, in opposite to this symmetric question, preferring a boring video over an excellent book. What we saw sometimes, what we see in the project documentations is that there are sometimes continuously, repeatedly errors students make. And this is very plausible because this modeling and formalization, although we give this guidance in the tool, and the parameterization of our guidance really requires the careful study and the application of the course material. And so we wanted to see how the participants handle our videos and how they handle our related book. And errors they have will, of course, errors they make will of course have a direct impact on our support effort and on the project success. To control this and to monitor this, we use control charts. And these control charts are also part of Six Sigma. And what you see here are the data of one of our course videos, and this reflects the audience retention. This data is publicly available. If you publish these in YouTube, you will get the data, download it, and you can apply the appropriate tools. So what we want here is to detect causes in our videos and our scripts of errors by detecting signals of the watch behavior of our students. And these control charts can give you some clues for the improvement by automatically detecting signals, for example, that students exit at start. So here is the amount of 100% of the students who joined the video in the beginning. And this is the decreasing performance over the video, also shown in 0 to 100%. So this is not in minutes, this is a complete video from 100% who started to the final students who watch the videos to its end. And what you can see here, some students have a repeated entry. So here the audience retentions in the beginning is larger than 100%. You can see intervals below average watch time. So this is the part here. We have the average here, and we have the average watch time here, and we have a large portion of this video below average watch time. We have certain outliers here and here at significant places. We have shifts in watch time, which is indicated by these dots here. So why does the watch behavior is increased, and why do students enter again? We have overall trends going down in this video, and we see what we also saw very often see, students again enter at the end of the video. So to summarize this, what we want is to get indications from the watch behavior of our students. If we experience errors in the performance of the students, try to trace them back to our course material, and of course, to improve our course material to reduce our effort. So I think the time is over. There would be just one slide, but this is not so important. Maria Miranda, I'm open for questions now.
Yes, thank you very much, Dr. Rainer Woodwacher, for your presentation, for your thought-provoking presentation. I have personally a lot of questions for you, but just maybe I also invite all the participants to insert their question in the Q&A box. So thank you very much. I will start with my question for you.
Yes, please.
I'm so much impressed about the structure and the design of the Six Sigma courses, especially thinking about critical thinking promotion. I linked this idea thanks also to Deborah Howe's presentation, the keynote speech that we had before. This design that you and your team created in your Six Sigma courses are so much close to critical thinking development, thanks also to the problem-based design approach. So can you please explain us the relation between the Six Sigma courses and transverse skills improvement?
And to what?
Transversal skills, critical thinking, in particular, promotion.
So I'm not sure whether I really can do this, but it's basically what we want. The key for our students is some generalized or generic knowledge and generic competence. This is very important for generalizing this approach to also other projects. And for me, I worked as a psychologist. I'm a natural scientist, and I think this is very important to be able to discriminate. So this is one of the basic competencies, I think a basic indicator of intelligence at all, to be able to discriminate. And then not only to be able to discriminate, but also to focus on certain attributes. What we want is that our students can focus on a certain object and that they can list and immediately see these and these are attributes. These are the attributes that make objects. So if you think basically an object, what we see as an object, a bicycle or a cookie, is nothing more as a spatio-temporal coincidence of attributes. So we have a taste, we have a texture, we have a shape, we have a weight. So anything we can observe can be broken down in attributes. And this is what we want to strengthen, that our students open their eyes and go around and see see differences and are able to discriminate things. This is the first, and the second one is then that they also are able to make assumptions about relationships. This affects that. So if we turn the setup of our timer, then the attributes of our cookies change. And not only for the cookies, but also for everyday life. So I'm sorry that I cannot relate this to certain topics you mentioned, but maybe this is
perfectly related. It's perfectly related, though, the idea to develop cognitive skills, and to think about how to use this kind of thinking methods in a very general and different context. So it's completely close to critical thinking. You mentioned, for example, relevance in your topic as an indicators of the activity students do in their courses. So I think it's so close with critical thinking and also with the main topic of our conference. So thank you very much. And another question for you is, can you deeply explain us the evaluation methods that are used in the Six Sigma MOOC? Because, for example, you share with us open-ended question related at the beginning of the session in the MOOC and closed questions. So how these data are used by you and your team in order to evaluate and monitor the learning path for the participants in the MOOC?
So very great questions. So the first important thing, this was more an impression. We started the certification project, implementing of the project 1 year ago. And I was not quite sure whether the material we offered would be suitable to work as a standalone, so that students would be able to implement only the project only based on the videos and on the tasks and on the tool. And luckily, the first projects we received were completely done without any lectures, so they didn't participate in the lectures. But this was the first great sign for me that it basically works. So there are students that have the capability to simply use the material without any additional support. But of course, what we see now, we have, for example, if you see what the most effort is for the business projects. And here we have a range between about 6 hours for very good student with a less complicated project, and it raises up to 20 hours for a student with a more complicated project. But this is also sometimes a mix. We have students with different prerequisites. There are some students who are already very familiar with statistics, and this is quite easy. For others, it's very complicated to get the ideas of a hypothesis, of testing hypotheses. So what we of course also monitor, not only the performance of our videos, but also of course the support effort we do, and we need to support our students. And we do this also, we also monitor the support not only for the direct support of the project, but additionally also for the management team. So you might easily can imagine that we have different sources of inquiries about the course itself, about its organization, about certification, about career and other things. And they post it in the discussion board. We get emails, we have them in our social media. And we also experience, hey, lots of these questions are already answered. And we, of course, answer them again, but we know this is a waste. So we try also to monitor which questions do we receive, which we already answered, and which are new, and how often do we need to forward certain inquiries so that it reaches the final addressee. So this is also another important aspect to monitor and to improve our project. Basically, it's the question, the success question is, does the participant successfully complete the project? And this can be clearly measured. So the application leads typically to a project success. It's my responsibility to declare this project is suitable, basically suitable. Then the student starts, and if the student will not be successful at the end of the project, it would be my fault. Basically, not the fault of the student. So we, of course, monitor and go back also if we see we missed something. So the monitoring of the performance is within the process. 5 review steps after each phase, feedback, please do it again. These are certain aspects you missed. And here we can, of course, see big differences in the competence and, most important, in the motivation. So some students very few are not motivated and they make the most effort. Yeah. So you can easily see they didn't watch the videos and they didn't look into the book. They do not complete the task. They just start, and this is immediately recognizable.
Yeah, for sure. A lot of work and impressive work, but there are a lot of congratulations from the chat, also from Mati Koivisto, that appreciate a lot the clear structure of the Yellow Belt education. So also my appreciation for my side. Thank you very much, Dr. Rainer Wood-Walker, for your presentation. So,
Maria, thank you so much.
Thanks to you. Thank you, and I'm very happy to kick it off the second presenters of the session, Dr. Igor Miladinovic and Dr. Siegfried Scheffer-Wenzel from the University of Applied Science campus in Vienna, Austria. I kindly ask Dr. Igor, I think, or Dr. Sigrid to share his screen. The presentation title is An Approach to Continuous Supervision of Bachelor's and Master Thesis in Engineering Studies. Igor Miladinovic is the head of the bachelor degree program Computer Science and Digital Communication, as well as master degree program Software Design and Engineering at the University of Applied Science campus in Vienna. He received a doctoral degree in electrical engineering from Vienna University of Technology in 2003. Between 2000 and 2005, he worked in telecommunication as researcher for Vienna University of Technology and Researcher Center for Telecommunication Vienna. In parallel, he worked as lecturer at 2 universities, teaching courses, Introduction to Telecommunication, Mobile App Development, Fundamentals of Mobile Business, and Ubiquitous and Pervasive Computing, and supervising master thesis and bachelor thesis students. So please, Dr. Igor Miladinovic and Dr. Sigrid Scheffer, you can start your presentation. I kindly ask to all participants to insert question and information suggested in the Q&A box or in the chat. So the presenters, the floor is yours.
Thank you for this introduction. Yeah, we are going to present you our approach for continuous supervision of bachelor's and master thesis in engineering studies. We also have written a paper about it, so you can find more information in the paper. Next slide, please. Thank you. In this talk, we will shortly talk about the goal and challenges of master's and bachelor's thesis, and then derive a categorization of different types of supervisors, and also present our approach, how we suggest to structure such a supervision process. And we can, with this process, we can address all supervisor types. So at the end of a study, students usually need to write a scientific final thesis. And in our talk, in our paper, we focused on bachelor's and master's thesis. And these theses should demonstrate the maturity and readiness of students to investigate a certain complex topic in depth. And this requires two major changes in student behavior, because students need to work more self-organized than in the rest of the study, and students need to deal with complex problems, while most of the other courses deal with complicated problems. So the major difference here is that solving complicated problems requires expert knowledge, and usually you can follow good practices, whereas complex problems need new solutions usually. Yeah, both Igor and I, we have a lot of teaching experience already, so more than 15 years, and we also have supervised a lot of theses in this time. And from this experience, and also from a literature survey, we can see that that the supervision process and how we structure this process is a very important aspect in how far students are able to successfully finish their thesis project. Therefore, we will first now talk about the goals and challenges of scientific thesis, and then present our categorization of supervisors that are categorized along two dimensions, responsibility and autonomy, and we will derive our recommendation for a supervising process which addresses all types of supervisors. Yeah, let's talk about the primary goal of bachelor's and master's thesis. The successful completion of a thesis should demonstrate several skills. For example, students need to have or need to show a deep understanding of a specialized topic, which in our case is the computer science domain in the bachelor program, and software engineering in the master program. Second, they need to demonstrate their ability to work in a self-organized manner, because there is usually no strict process to follow in order to be successful. And finally, another critical success factor, as we call it, is that students need to have social skills to cooperate with a supervisor or supervisors, and also stakeholders in a company for theses that are done in collaboration with our industrial partners. And all these skills are also highly demanded by the industry, and therefore we define as our ultimate goal of a thesis that students, that a thesis should prepare students for their careers in industry. And this is shown in this goal tree at the top. So the major goal of bachelor's and master thesis, as we see it at our university, is that it should prepare students for their future careers. In order to develop these skills that are required to achieve the goal, there are also several necessary conditions that are listed or shown at the top of this figure. For example, students need to be able need to conduct an extensive literature review. They also need to formulate a scientific research question. And if these conditions are met, they are able to deepen their knowledge in this advanced topic. And there are several other conditions, necessary conditions, that are related with developing these skills. And if we now look at the challenges of a thesis, so we have seen that a bachelor's or master thesis is expected to be good preparation for the student's further career. However, we still see that there always is a number of students who are not able to successfully complete their thesis, even though they have successfully completed all other parts of their studies. And we have analyzed this situation. I have to mention that at our university, we have strict deadlines for students to submit their final thesis. So for every student, there are 3 deadlines. And if he misses the last deadline, the 3rd deadline, he or she cannot finish their study. Therefore, we have defined as the most undesirable effect in the context of supervising bachelor's and master's thesis that students cannot meet their deadline. So they cannot hand in their thesis in time. And in this figure, we analyzed the main reasons leading to this effect in a so-called current reality tree. We focused on this one undesirable effect, as it is the most undesirable effect. And we have identified 3 causes that lead to this undesirable effect. And these 3 causes are, for example, insufficient writing skills of students, or a lack of self-learning skills, and a lack of time. So these are the main reasons for not meeting the deadline. We have further analyzed these reasons. I will not go into detail here, but only show the main root causes. So there are usually always root causes for each undesirable effect we can witness. And we have identified these 2 root causes, which are that in our study, we had a very strong focus on developing technical skills in our study. It is an engineering curriculum, and we had a very strong focus on these technical skills. So therefore, students, or a part of students, were not able to further develop their writing skills or develop their other social skills. Another root cause we identified was insufficient supervision. And we addressed these both root causes. The first root cause was addressed by introducing several soft skill subjects into our curriculum. We also have several subjects where students have to write little papers, seminar papers, and which prepare them for their thesis. And we have developed a supervision process that should address different types of students as well as different types of supervisors. And I will now hand over to Igor, who will present you these findings.
Okay, thank you, Sigrid, for the introduction. So now we basically are familiar with the situation. We have analyzed what is going well, what is going not so well. And out of this, we have derivated this figure. We defined two dimensions of supervising. The first one is the responsibility, whether the responsibility is with the supervisor or with the student. Of course, if you take this x-axis, they are not just two types, so supervisor or student. They are a continuous axis, meaning that the amount of the responsibility which lies at students can be more or less, and from 0 to full responsibility with students. And this is something which is which depends on the supervisor himself or herself. So we are all somewhere on this axis. Either we trust the students or a lot, or we trust the students not so much. And the y-axis is autonomy. And this is more with the students. We have different students. Some of them are self-organized. Some of them are not very well organized, and they need strong guidance. Also, this axis, y-axis, is not with just two values. It's continuous axis, so the students with very strong guidance and fully self-organized or some self-organized to some extent, everything is possible. And based on these two dimensions, we defined 4 quadrants. The first one is a controller, which is a supervisor type who feels responsible for the outcome of the thesis, and the students who need strong guidance. And then gatekeeper, meaning the students are self-organized, but I would like to have a full control as a supervisor. So I will define some milestones and act as a kind of gatekeeper. So I will define the gates, and the students need to pass these gates. And then for the supervisors which leave the responsibility to be with the students, if the student needs a strong guidance, then it's a kind of supporter, a coach, a lot of discussions, a lot of literature recommendation, a lot of support. Or here, if the student is self-organized, it is a kind of coach. It's kind of coaching in the sessions which are just small corrections of the direction of the development of the thesis if necessary. And we see now, even if we define for ourselves a supervisor where we are here on this x-axis, we need to act differently depending on the students which we are supervising. And this was also our goal. We wanted to design a process which is not a fixed process, but which is a process which will be adapted according to the needs of students. So we wanted to have a kind of individualized process for each student, so that each student can get support which he or she needs. And we divided this process in the development of the process. We defined 4 phases. And with this process, we want, actually what we want to do, we want to address this insufficient supervision from this diagram with challenges which Sigrid has shown to you, this one. So we want to address this point. As Sigrid already mentioned, for this point, we introduced several soft skills or professional skills courses, which is not the topic of this presentation. And now we focused on this root cause. And here you can see the complete process from the beginning until the end of the supervision. We start usually in the semester before the actual start of the thesis. We present all the possible topics. It's a kind of pool of topics and pool of supervisors. And the students are able to vote for these topics. It's a kind of priority voting. Each student will have priority 1, 2, or 3 for the topic. And then we are making related groups together, usually 4 to 7 students in one group with the related topics. And this group will be then supervised by one supervisor, which is responsible for this topic. In the second phase, we start with explanation of the process, with explanation of expectations. This is at the beginning of semester where the thesis takes place, and it is very important to obtain a very early feedback on a research question, on the contents, on the writing style. So usually we define a deadline for the first 5 pages and the research question and the first literature, and then the students are getting this early feedback, so we are able to correct if something is going in the wrong direction. We are able to correct it very early, and this is meant by this early feedback. And we also work with best practice examples. There are some very good theses which we are just giving to students just to show how it should be, also what is expected from a thesis. Because as Sigrid told at the beginning, this is the first time maybe for some of them to be to deal with a complex problem, to be more or less forced to work self-organized, to look for literature. There is no book or something like that as for a classical examination. It is self-organized work. And the third phase is actually the phase with the longest duration. This is the complete semester. It's a kind of incremental process. The students are submitting more and more of the thesis, another 10 pages, another 10 pages, or chapter, and it needs not to be amount of pages. And they are getting the feedback, timely feedback on these submissions. This is also important because if they submit something and they are 2 weeks without the feedback, then it is they are not motivated to write more, because they have a feeling that it makes no difference to submit something or not. So timely feedback is very important. This is at least our experience. We also work with peer feedback. So the other students are reading the thesis of one student and giving him or her feedback. But at the end, there is a final feedback. There's a peer review. So each thesis will be reviewed by at least 2 other students. And we have a kind of retro, what worked well, what could be optimized. And there is a final submission at the end, which is official submission. And this is the work, the thesis, which will be graded. So, concluding, we have presented this concept. We introduced the concept in order to increase success rate for the bachelor and master thesis, or if you want to reduce the dropout rate. And we started with just 2 groups out of all groups with this process, and we have seen, also we have experienced much more students which were able to finish the thesis on time in these 2 groups. And today, almost all supervisors at our university work with this concept. Not because they have to work with this concept. It's still an option, but the majority of them accepted this concept because it is because of the success rate. And the bottom line, the key success factors in a master or bachelor thesis, the process and the expectations needs to be communicated at the beginning, support and feedback from the beginning on, and support has to be individual, and we need to design an environment where the students will work continuously on the thesis. So that it is not the solution to write a thesis in the last 2 weeks of semesters. It must be also the best way is to start at the beginning of semester and to work continuously on the thesis, and the intermediate feedback is also important to see whether it is going in the right direction or not. So thank you very much for your attention. Sigrid and I are now open for questions.
Thank you very much, Sigrid and Igor, for your powerful presentation. I have a question on two questions for you from the Q&A box. The first one I think is linked to Sigrid's presentation, the first part of your presentation. Matic, I visto ask, you pointed out that you have strict deadlines. Is it so that if the students do not meet the third deadline, he or she cannot graduate? If so, what is your dropout rate? Is an important challenge.
Yes, for each exam and also for the bachelor thesis or master thesis, we always have 3 possibilities. And if students do not submit their thesis the third deadline, they cannot, they have the opportunity to repeat the year, and then they can still finish the study. But if they also miss these 3 deadlines from repeating year, then they cannot finish their study. So this is the system of the universities of applied sciences. They want to encourage students to finish their study in time, and therefore students have strict deadlines where they need to submit their thesis.
And this is why these guidelines that you share with us are so important, not for your university system. And the second question is, are all the topics given by the university and students select from them, especially regarding the first phase topic selection?
Mm-hmm. So we have a pool of supervisors, about 15 supervisors, and each of them is proposing some topics, usually 3 to 5 topics. They're not given by the university, they are coming from the supervisors. So if you see supervisors as a part of the university, then you're right, they are given by the university, but they are individual of the supervisors. And we have a mix of supervisors. Some of them are working for the industry and teaching at our university part-time, and some of them are full-time at the university. So the topics are, the majority of the topics are coming from the industry. And the students also have the possibility, they are, if they work for a company and the company is also active in a research, they can also propose an own topic, and if you have one supervisor which can supervise this topic, this is then also possible. And the students, there's then a number of topics, about 40 topics, let's say, and the students are able to select between these topics.
Okay, this is so close to the Italian university system, so thank you. One question from the chat box from Rainer. Do you also experience repeated specific effort to clarify contents that you already explained? For example, meaning some kind of waste that you could reduce? Thank you.
Mhm.
Yes, of course, we need to repeat several things, but we also have checklists, for example, regarding formal aspects like how to do the caption for a figure or how to cite or something like that. But of course, there are several things we need to say more often. But as we do the whole discussions in group, students also learn from other feedback. So when we discuss one thesis, there may be things that other students can also take for their thesis. So yeah, we experienced it as a very efficient process.
So thank you very much, Sigrid and Igor, for your presentation. I kindly support all the participants also to use the WOVA app and ask specific questions to our presenters for this session through the app. And thank you so much. Please enjoy the conference. And thanks also to Miranda that support us as part of the conference team.
Okay. Thank you also for the perfect moderation.
Oh, thank you to you.
Right, I will close this down.